Hello all, welcome back to our channel Enjoy Learning. For today's video, we are going to do classification of haloalkanes and haloarenes. This video it will be useful for the students of 12th Science CBSE board. So now we will start with the video. So before going to the classification, first we will see what do you mean by haloalkanes and haloarenes. So when you have a halogen atom attached to the alkyl group, it is called as haloalkane. The common name is alkyl halide. And when you have a halogen atom attached to a rene, that is benzene ring, it is called as haloarene. The common name is aryl halide. Starting with the classification of haloalkanes and haloarenes. This classification it is based upon the number of halogen atoms attached to the carbon atom. So in that, the first class is monohalogen, dihalogen, and polyhalogen. Under monohalogen, you have subclasses, which we will see in the later part of the video. So, as we have said, halogen atoms, it can be monohalogen, dihalogen, or polyhalogen. Okay, so depending upon whether halogen atoms are one, two, or more, they can be named as monohalogen, dihalogen, and trihalogen. So for haloalkanes, when you have one halogen atom attached to the alkane, it is called as monohaloalkane. When we have two halogen atoms attached to the alkane, it is called as dihaloalkane. And when we have three halogen atoms attached to the alkane, it is called as trihaloalkanes. The same case follows for arenes. When you have one halogen atom attached to arene, it is called as monohaloarene. For two halogens, it is called as dihaloarenes. And for three halogen atoms attached to the arene, it is called as trihaloarene. Now, monohalo compounds they are further subclassified according to the hybridization of carbon atom to which halogen is bonded. In that, the first subclass is on the basis of compounds containing sp3 hybridized carbon bonded to halogen bond. In that, we have three alkyl halides or haloalkanes. Second one is allylic halides, and the third one is benzylic halides. And the second subclass is on the basis of compounds containing sp2 hybridized carbon bonded to halogen bond. In that, the first one is vinylic halide and the second one is aryl halide. Now coming to the first subclass, that is on the basis of the compounds which contain sp3 hybridized carbon halogen bond. In that, the first one is alkyl halides or haloalkanes. Now, as per the homologous series, alkyl halides they can be represented as CN H2N plus 1 X. Okay, so when we have a halogen atom which is attached to the primary carbon atom, the alkyl halide is called as primary alkyl halide, or it is represented as 1. Give a degree alkyl halide which represents primary alkyl halide. Then if halogen it is attached to secondary carbon atom, the alkyl halide is called as secondary alkyl halide. And if the halogen atom it is attached to the tertiary carbon atom, the alkyl halide is called as the tertiary alkyl halide. Now we will look with the structures. So in the first structure, we can see we have a halogen atom which is represented in green, which is bonded to carbon atom, and that carbon atom it is bonded to only one alkyl. So it is called as primary alkyl halide. In the second structure, we have a halogen which is bonded to carbon atom, and that carbon atom, it is bonded to two alkyl groups. So it is called as secondary alkyl halide. And the third case, wherein we have a halogen atom which is bonded to carbon atom, and that carbon atom, it is bonded to three alkyls, and hence the name is tertiary alkyl halide. The second one is allylic halides, the compound in which the halogen atom is bonded to sp3 hybridized carbon atom adjacent to carbon-carbon double bond, that is to an allylic carbon. Look at the structure. In this structure, we have halogen Cl. This halogen atom, it is bonded to the carbon atom. This carbon atom CH2, it is sp3 hybridized, and it is bonded to the carbon atom which has double bond. This structure, it contains allylic bond. Okay, so the carbon atom, that is CH2, which is bonded to Cl, it is allylic carbon atom and it is sp3 hybridized. Come to the second structure. Again, you have halogen atom which is bonded to allylic carbon atom. Allylic carbon atom is the carbon atom which is bonded to the carbon atom adjacent to it, which contains a double bond. Coming to the third one, that is benzylic halides. So benzylic halides are the compounds in which halogen atom is bonded to sp3 hybridized carbon atom which is attached to aromatic ring. Come to the first structure. So you have halogen atom, that is Cl. It is bonded to sp3 hybridized carbon atom, that is CH2, in that you have carbon atom, and that carbon atom, it is bonded to the aromatic ring. The name is primary benzylic halide. Come to the second structure. The same case, you have halogen atom which is bonded to sp3 hybridized carbon atom, but that sp3 hybridized carbon atom, it is attached to one alkyl group, and hence the name is secondary benzylic halide or chloride in this case. Look at this third structure. In the third structure, we again have halide Cl, which is attached to sp3 hybridized carbon atom, which is attached to two alkyl groups, and hence the name is tertiary benzylic halide. Tertiary because two alkyl and the third one is aryl. Secondary benzylic halide because it is attached to one alkyl and one aryl. And primary benzylic halide because it is only attached to one aryl. Coming to the second one, that is on the basis of compounds containing sp2 hybridized carbon halogen bond. In that, the first one is vinylic halides. So these are the compound in which the halogen atom is bonded to sp2 hybridized carbon atom of carbon-carbon double bond. So look at the structure. We have a halogen atom. This halogen atom, it is bonded to sp2 hybridized carbon atom of double bonded carbon atom. Okay, halogen attached to the carbon atom which is immediately bonded to second carbon atom by a double bond. So this is called as a vinylic halide. Look at the second example wherein we have shown a cycle. So you have a halogen atom which is bonded to the carbon atom and which is immediately bonded to the next carbon atom having a double bond. Coming to the last one, that is aryl halides. So these are the compound in which the halogen atom, it is directly bonded to sp2 hybridized carbon atom of the aromatic ring. So as the name suggests, aryl means there is going to be an aromatic ring. So you have a halogen it is bonded to the carbon atom of the aromatic ring which is sp2 hybridized. The second example, again we have a halogen atom which is bonded to the aromatic ring and which is sp2 hybridized. So with this, we come to the end of the video. If you liked with the content of the video, kindly like, share the video and subscribe to the channel. Thank you all.